Okay, space exploration. It really it pulls you in, doesn't it? Just the sheer ambition of it all, the amazing engineering, and, the chance to uncover these huge secrets about our universe.
Absolutely. And there's one mission right now that's getting a lot of buzz, a really big step for China's space program. It's called Tianwen-2.
Tianwen-2, right. And for this deep dive, we're looking at its target, which is, well, pretty intriguing itself.
It really is. They're not heading to just, any old asteroid. They're going for a near-Earth object
Yeah.
with this kind of beautiful name, Kamo'oalewa. Sounds Hawaiian.
Kamo'oalewa. Okay. And our guide for this deep dive, our main source, is a recent report in the Indian Express.
Yeah, and that report does a great job explaining why this isn't just another rock.
Yeah.
It highlights this really almost mind-blowing idea that scientists have,
Which is?
that this little asteroid might actually hold clues to, well, maybe the single most dramatic event in our solar system's early history. We could be talking about the birth of our own moon.
Whoa. Hold on. A piece of the moon's birth. That's massive potential.
Exactly. So that's what we're unpacking today. We'll dig into what Kamo'oalewa actually is, why scientists think it's so special, and, why China's launching this really complex mission to try and grab a piece of it.
And how they plan to do that, because it sounds tricky. Plus, crucially, why this matters to you listening. Whether you follow global science, or you're just fascinated by space, or maybe you're tracking current events for, say, general knowledge or even UPSC exam prep.
Right.
Understanding this mission gives you a real insight into where science is heading. So let's get into it.
Okay, so first up,
Uh-huh.
what is Kamo'oalewa?
Well, astronomers first spotted it back in 2016. The Pan-STARRS telescope in Hawaii picked it up.
And it wasn't just another near-Earth object, right? It stood out.
Yeah, it stood out immediately because its orbit is, well, it's weird. It's classified as a quasi-satellite of Earth.
Quasi-satellite.
And there aren't many known, maybe only 7 or so objects like it.
Okay, quasi-satellite. That sounds kind of technical. What does it actually look like it's doing from down here on Earth? Well, that's the really interesting part. From our perspective, Kamo'oalewa looks like it's orbiting Earth. It seems to be doing this kind of looping dance around us.
So it looks like a moon, but it isn't really.
And not exactly like our moon, no. The moon is, gravitationally locked to Earth. Kamo'oalewa is actually orbiting the sun, just like Earth is.
Ah, okay.
But its path around the sun brings it so close to Earth, and Earth's gravity influences it so much that it stays nearby. It kind of leads us, then trails us in our own orbit.
So it gives the impression of orbiting us, even though the sun is the main dance partner.
Exactly. Think of it like Earth's temporary, slightly odd companion as we both go around the sun.
A cosmic dance partner. How long has it been doing this dance? Is it stable?
Well, the Indian Express report mentioned it's likely been in this sort of configuration for about 100 years. And they expect it to stay like this for maybe another 300 years or so.
Not permanent then.
No, these quasi-satellite orbits, they tend to shift over much longer time scales. They're not forever stable.
And size-wise, we're not talking planetoid here.
Oh, definitely not. It's tiny,
Right.
really small. Estimates put its diameter somewhere between only 40 and 100 meters.
40 to 100 meters. That's
So,
surprisingly
yeah.
small for all this attention.
It is, and that small size, as we'll get into, is actually a massive part of the challenge for the mission itself.
Right. Which leads us straight to the big why. Why this specific, tiny, oddly orbiting rock? Why is China pouring resources into the Tianwen-2 mission to go there?
Well, the first big driver is just the mystery of it, that unusual orbit, and the fact that we really don't know where it came from. How do objects become quasi-satellites? How do these orbits work? It's a poorly understood category of objects near Earth.
Okay, solving the orbital puzzle. But then there's the really exciting possibility you mentioned earlier, the one that could change how we see things.
Exactly. This is the headline grabber. There's a very compelling theory put forward by researchers like Benjamin Sharkey and his team in a 2021 study that suggests Kamo'oalewa might not just be some random asteroid captured in a funny orbit. They think it might be the very first asteroid we've ever found that's made of material ejected directly from the moon.
From the moon itself? How does a piece get knocked off the moon and end up doing this?
The thinking is, a major impact event on the moon's surface billions of years ago could have blasted material off with enough force to escape the moon's gravity.
Okay.
And Sharkey's team, they use a big telescope to look very closely at the light reflecting off Kamo'oalewa. Basically, its spectral signature, its chemical fingerprint.
Right, analyzing the light.
And what they found was pretty stunning. The pattern of reflected light suggested it's made of silicate materials, basically, rock types that are incredibly similar to the rocks the Apollo astronauts brought back from the moon.
So the color of the rock essentially matches moon rock samples we have here.
In a spectroscopic sense, yes. The match was remarkably close, which is persuasive, as you said, but then you connect it to the really big picture.
The formation of the moon itself.
Exactly. The leading theory for that is the giant impact hypothesis. Billions of years ago, a Mars-sized protoplanet, sometimes called Theia, slammed into the very young Earth.
A massive collision.
Huge. It would have thrown an enormous amount of molten rock and debris into orbit around Earth, and that debris eventually came together to form our moon. Now imagine the sheer amount of stuff flung out by that impact.
There must have been fragments everywhere.
Precisely. And the idea is Kamo'oalewa could potentially be one of those leftover pieces. A small rocky survivor, a relic from that incredibly violent event that formed our moon.
Wow, a literal piece of the moon's origin story just floating nearby. Okay, now I see why getting a sample is the holy grail here.
Exactly. As astrophysicist Amy Mainzer was quoted saying, the telescope data, the orbital models, they're all very suggestive, very interesting. But the only way to really know, to settle the question of origin definitively, is to get a piece back into a lab on Earth.
Yeah, you can't beat having the actual material in hand.
No substitute for ground truth, or rather, space truth brought to the ground.
So the takeaway here, the so what, for anyone tracking this, is huge. Figuring out where Kamo'oalewa came from isn't just about one quirky asteroid. It could tell us so much.
It really could. It could help us understand how quasi-satellites form and evolve. It could provide direct, physical evidence supporting the giant impact theory for the moon. And it gives us this amazing window into the conditions of the very early solar system.
So this mission is tackling some really fundamental questions in planetary science.
Absolutely. It's right at the cutting edge. The potential scientific payoff is enormous.
Okay, so scientifically fascinating, potentially a piece of the early moon, but practically speaking, how on Earth, or rather, how in space, does China plan to get a sample from something so small with hardly any gravity doing this complicated orbital dance?
Yeah, that's where the engineering challenge really ramps up. It's incredibly difficult. The main technique they're planning to use is something called touch and go.
Touch and go, like a quick tap.
Sort of, yeah, but incredibly precise. It's a method that's been used successfully before. Japan's Hayabusa 2 mission did it at asteroid Ryugu, and NASA's OSIRIS-REx did it at Bennu.
Okay, so there's precedent. How does it work?
The spacecraft gets very close to the surface, maybe hovers just above it, or makes a very brief touchdown. Then it uses some kind of mechanism, maybe firing a puff of gas or even a small projectile to disturb the surface material, kick up dust in small fragments,
Right.
and then collect those floating fragments into a special chamber.
A delicate little cosmic dust-up and collection?
Pretty much. But the source material, the Indian Express report, also mentioned they have a plan B.
Always good to have a backup.
Definitely. If the surface is too tricky for touch and go, they might use an anchor and attach method. That would involve extending robotic arms to actually grip onto the surface, maybe anchor themselves, and then possibly drill to get a sample.
Wow, okay, more involved. So they get the sample one way or another. Then what?
Then the plan is for the main spacecraft to head back towards Earth and release a capsule containing those precious samples. That capsule re-enters the atmosphere and lands, hopefully gently, so scientists can retrieve it.
And is that the end of the road for the Tianwen-2 probe itself?
Apparently not. The report suggests it's got more work to do. After dropping off the Kamo'oalewa sample, the probe itself is scheduled to fire its engines and head out towards the main asteroid belt.
Really? For another target?
Yeah, for a second mission phase, potentially studying another asteroid out there. So it's quite an ambitious multitasking plan.
It really is. But let's go back to the challenge you mentioned, Kamo'oalewa's tiny size. Why does being small make sampling so much harder than, say, Bennu or Ryugu, which were also sampled?
That's the absolute crux of it. Tiny size means minuscule gravity. It's almost negligible.
Right.
So unlike approaching a larger asteroid where there's some gravitational pull to help stabilize the spacecraft or keep things predictable, Kamo'oalewa basically has none. Trying to touch its surface is it's incredibly delicate.
Like trying to land on a feather floating in space without blowing it away.
That's a pretty good analogy, yeah. You need extreme precision. The report specifically calls out the need for incredibly advanced technology. We're talking state-of-the-art cameras for navigation and mapping in real time.
Mm.
Really powerful onboard computers that can make split-second adjustments, and super responsive reaction control systems, tiny thrusters, to keep the spacecraft perfectly oriented and stable during that critical moment of contact or hovering.
It sounds like a huge technological feat they're attempting.
It really is. It pushes the boundaries of autonomous spacecraft control and navigation.
Okay, so let's just pull these threads together. We've got this really small, very unusual asteroid, Kamo'oalewa. It might actually be a leftover piece from the moon's formation billions of years ago.
Right, and it's following this strange quasi-satellite path near Earth,
Yeah.
influenced by our gravity but mainly orbiting the sun.
And China's Tianwen-2 mission is this incredibly ambitious attempt to get there, use these complex touch-and-go or anchor techniques to grab a sample. Yeah.
And bring it back to Earth, potentially solving the mystery of where it came from and rewriting some history books.
This isn't just, another space mission. It's a fantastic example of where space exploration is right now. It really puts China up there with the US and Japan in terms of advanced asteroid sample return capability.
Absolutely.
So for anyone tracking global science, tech developments, or just interested in the big questions about where we came from, maybe for general knowledge, maybe for preparing for something like UPSC, this mission is a really key thing to understand. It's about pushing boundaries, incredible engineering, and that fundamental scientific drive to understand our cosmic neighborhood.
It's turning light patterns seen through telescopes into actual rock we can hold and study. That's a huge leap.
It really is. And it leaves us with a pretty cool thought to chew on, doesn't it?
Which is?
Well, if Kamo'oalewa is a fragment from the moon's birth, could there be other pieces like it out there? Other little remnants from that giant impact, maybe in different kinds of orbits, just waiting for us to find them?
That's a fascinating possibility. What else could we learn about the solar system's chaotic beginnings by finding and studying these small, unusual objects?
It definitely opens up new avenues for exploration.
For sure. A whole new potential population of objects to look for.
It really does. Well, this deep dive into Kamo'oalewa and Tianwen-2 got you thinking. If you found it useful for tracking current events or just for your own curiosity,
Let us know.
yeah, please do. Drop your questions or thoughts in the comments below. We do read them.
Your feedback really helps us figure out what deep dives to do next.
Absolutely. And of course, make sure you like and subscribe so you don't miss out on future explorations like this one.
And just to reiterate, this deep dive, looking at the science behind Kamo'oalewa and the Tianwen-2 mission, was based on reporting from the Indian Express.
Great stuff. Thanks for joining us on this deep dive.
Catch you next time.